Welcome to the Fault Tolerant Operations training module. In this module, you'll be provided with an overview of the ztC Edge Fault Tolerant process, as well as how to configure a fault-tolerant virtual machine. The ztC Edge software provides two user-defined availability levels for VMs, High Availability, or HA, and Fault Tolerance, or FT. Both HA and FT can handle failures without IT intervention. Both provide continuous active validation of all components and assures redundancy and recovery at all times. In both operations, the ztC Edge software transparently protects an application by creating a redundant environment for a VM running across two physical machines. Let's look at each protection level in detail, starting with HA. The HA operation offers basic failover and recovery, with some faults requiring an automatic VM reboot for recovery and then a return to HA operation, while in a fault-tolerant operation, an application continues to run without downtime during the fault. HA eliminates downtime for many, but not all, CPU, memory, I/O, or other physical machine failures. HA is suitable for applications that can tolerate occasional interruptions of a few minutes during the reboot of the VM. An FT operation transparently protects a VM from all faults with no downtime. An FT operation ensures no data loss, provides continuous active validation of all components, assures complete redundancy and recovery at all times, and, unlike HA, eliminates downtime due to any CPU, memory, I/O, or other physical machine failure. You would utilize FT for applications that need the highest levels of availability. A process named checkpointing is what differentiates fault-tolerant operations from high availability. Checkpointing refers to the periodic maintenance of changed memory pages copied over the A-Link networks to maintain the ready status of a redundant guest operating system with the most recent copy of memory and CPU context of the active VM. Each state of copying memory pages, also known as changed or dirty pages, and CPU context to a ready VM is referred to as the checkpoint cycle. When a failure requires activation of the guest OS on the redundant physical machine, the ready guest VM is made active. With checkpointing, time is balanced between running the guest OS, fundamentally good performance, and actively checkpointing, or fundamentally no performance. The active VM is paused, that is, it's not running, for a portion of the time to complete each checkpoint cycle. The checkpoint engine stops the guest OS from executing. It then performs a number of steps to complete a checkpoint cycle. As soon as possible, the guest OS is resumed. The frequency of checkpoint cycles varies with the characteristics of the applications running on the guest. For example, lightly loaded systems will run 50 to 100 times per second or less. Systems with extreme loads, 600 to 1,000 times per second. And a typical workload might checkpoint between 300 and 400 times per second. Let's see how checkpointing is performed. In a ztC environment, there will be an active node and a standby node. The active node's VM's I/O is paused for a portion of time to complete each checkpoint cycle. During the checkpoint cycle, the active node sends its state to the standby node. The standby node receives the checkpoint data, and once the checkpoint state is committed on the standby node sends an acknowledgement back to the active node, where the checkpoint process releases the held I/O. This checkpointing cycle continues as long as the VM is running. In addition to synchronizing memory, the checkpoint operation also queues I/O requests that occur between the end of one checkpoint and the end of the next. This is done so that no I/O operations are performed on the active node until the standby node acknowledges that the memory mirroring has been completed on the standby node. This ensures that no I/O is lost between nodes during any failure. If a failure on the primary node occurs, the standby node will continue from the last successful checkpoint. All queued and unacknowledged I/O operations are discarded. The standby node will run the same code that produced the I/O operations on the primary so that no data is lost or duplicated. This process provides continuous availability with no data loss, even if the active node fails. Let's now look at how to create a fault-tolerant virtual machine. To create a fault-tolerant virtual machine, from the dashboard page, click Virtual Machines in the left navigation panel. Once in the Virtual Machines page, click Create in the upper right-hand corner to create a new VM. Provide a name for the VM, an optional description, and then select Fault Tolerant to create your fault-tolerant VM. Fill in all additional information for the VM. Please note that the creation of a VM may take several minutes or longer. The process has been expedited in this video. Once the VM has been created, you can see that it is an FTVM under the Protection column. This completes the Fault-Tolerant Operations training module. Thank you for viewing this module.